All right, so we're going to go ahead and simplify cube roots today. Okay, we're going to simplify cube roots, but let's recall our square roots again. Okay, all right, so we have 3 radical 5 over radical 7. Okay, and this is not in simplest form because we cannot have a radical in the denominator. Okay, so we have to rationalize our denominator. So once again, that means we're going to multiply the numerator and the denominator by the radical in the denominator. So the radical in the denominator is radical 7. Okay, so we're going to multiply radical 7 over radical 7, which just means 1, so we're keeping it the same. So 3 radical 5 times radical 7, the 3 stays on the outside, and radical 5 times radical 7 is 35. Okay, and when I look at 35, I would see if I could break it down, but it breaks down to 5 and 7, which there's no pair, so I'm not going to worry about that. Over, now radical 7 times radical 7 is just radical 49, but if you notice, it was broken down to 7 and 7, so I'm just going to circle a 7, cross a 7 out, so the 7 comes on out. Okay, then I would always make sure, can I simplify radical 35? No, we already talked about it. And then I would see, can I simplify my outside numbers, the 3 and the 7? No, I cannot. So that is my final answer. Okay. Now, number 2, we can do number 2 a couple different ways. The first way is I notice that I have the square root of 3 over 18. So I could just break that down to radical 3 over radical 18. And then I could multiply the top and the bottom by the radical because I can't have a radical in the denominator, okay? And I get multiplied by radical 18 over radical 18, okay? Now from there, they're both under the radical, so 3 times radical 18 would be the square root of 54, excuse me, over. And then 18 and 18, they're the same, so I can go ahead and circle one, cross one, so 18 comes out. And then I see, can I simplify 54? Yes, I can. Okay, that would have broken down to 3 and 18. And then 18 breaks down to 9 and 2, and 9 breaks down to 3 and 3. So radical 54 is 1, 2, 3 3s and a 2. So then I look for a pair. I have a pair of 3s, so I'm going to circle a 3, cross a 3, so my 3 comes out. So I'd have 3 radical, and I have a 3 and 2 underneath, so that's going to stay. So 3 times 2 is 6 over 18. And then I check my outside numbers. Can I simplify 3 and 18? Yes, I can. 3 over 18 is 1/6, so I'd have radical 6 over 6. Okay, so that's one way. Another way is I look at, before I even multiply by radical 18, I look at 3/18 is underneath the radical, it's a fraction. Can I simplify 3/18? Yes, I can. I can simplify that to 1/6. Now I could break it down to the square root of 1 over the square root of 6. And then I'd multiply by radical 6 over radical 6. So radical 1 times radical 6 is radical 6, and radical 6 times radical 6, they're the same, so I'm going to circle one, cross one, and I just get 6. So I get it a little bit quicker that way. So I always try to see, can I simplify inside that fraction first before I actually multiply by that radical, okay? All right, cube roots. Okay, so we've talked about cube roots back in chapter 6, okay? So a cube root, like our perfect cube, is 1 times 1 times 1. So 1 cubed is 1. Then 2 cubed, so 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64, okay? So those are like your perfect cubes, okay? Now, once again, simplifying cube roots is the same as square roots, okay? There's 2 methods. We can use our perfect cubes, but a lot of times people don't have those memorized. So I think the prime factorization way is the easiest, okay? Now, the difference here is we're not looking for pairs anymore because my index is a 3, it's a cube root. We have to look for triples, okay? And then once I find a triple, I'm going to circle one of them, and I'm going to cross out 2, okay? Because the cube root of 27 here is 3 times 3 times 3, so the number that occurs 3 times is just 3, okay? So we cross out 2. All right, so let's break down 128 here, okay? Our index is 3, so we have to look for triples, okay? So 128 breaks down to 2 times 64. 2 is prime. 64 breaks down to 8 and 8. 8 breaks down to 4 and 2. 8 breaks down to 4 and 2. Okay. My 4 breaks down to 2 and 2. This 2 is prime. 4 breaks down to 2 and 2. This 2 is prime. And those all 2. So how many 2s we got? 1, 2, 3, 4, 5, 6, 7. So 7 2s. We keep that little index of 3. So 1, 2, 3, 4, 5, 6, and 7. So now we look for cubes, triples. So I have 3 2s, and I have 3 2s, and a 2 left over. Okay. So now I circle one of my 2s, and I cross out 2 of them. I circle one of my 2s, cross out the other 2. The last 2 has to stay where it's at. Okay. My circles come out. So 2 times 2, and we have the cube root of what's left under a 2. So 2 times 2 is 4 to the cube root of 2. Okay. All right, let's go ahead and go sideways here. So the cube root of 125, x to the 7th. So let's break down 125. 125 breaks down to 5 times 25. 5 is prime. 25 breaks down to 5 and 5. Nice. So we have the cube root of 3 5s, 1, 2, 3, and 7 x's, 1, 2, 3, 4, 5, 6, 7. So we look for triples. I have a triple 5. I have a triple x. I have another triple x, and then I have a singleton x. So that one will stay. Okay. So we circle 1 5, we cross out 2 of them. We circle one of the x's, we cross out the other 2. We circle an x, we cross the other 2 out, and that last x is going to stay. So my circles come out. We have 5 and 2 x's, and then we have the cube root of x. Okay, and 2 x's we're going to rewrite as 5x squared, and then we cube root of x, and that would be your final answer. Okay. All right, let's look at number 2 here. Okay, so we have 3 times the cube root of negative 125. Now remember, negative, 3 negatives multiplied become negative. So as soon as you see a negative in that radicand, we're going to pull that negative out. So that could be rewritten as negative 3 cube root of 250. Okay. Now let's break down 250. Okay. Ends in a 0, so I always do 10. 10 times 25. 10 breaks down to 2 and 5. Those are both prime. 25 breaks down to 5 and 5. Okay. So we have negative 3 on the outside, the cube root of 1, 2, and 3 5s. So it's cube root, so we look for a triple, and I see a triple 5. So I'm going to circle 5, cross a 5, cross 2 of them. Okay, this 2 is a loner, so it stays right there. This 5 is going to pull out. So negative 3 times 5, and then we have the cube root of 2, and then we multiply. So negative 3 times 5 is negative 15, and then we have the cube root of 2, and that would be your final answer. Okay. Excuse me. Number 5 here, we have the cube root of y over 216. Okay, same concept as square roots. Okay, so we're going to go ahead and we're going to do the cube root of y over the cube root of 216. Okay, now let's go ahead, before we multiply, rationalize anything. Let's see if 216 can be broken down. And I know 216 can be broken down. Okay, let's make it easier on ourselves. Okay, so 216 breaks down to 2 and 108. Okay, 2 is prime. 108 breaks down to 2 and 54. 54 breaks down to 2 and 27. 2 and 27. Okay, let's go over here, 2 and 27. 27 breaks down to 3 and 9. And 9 breaks down to 3 and 3. Okay, so we have 1, 2, 3 2s, 1, 2, 3 3s. Okay, so we have, so for 216 we have 3 2s and we have 3 3s. So we look for triples. Oh, we have triple 2 and triple 3. Nothing left over, which is nice. So circle a 2, cross a 2 2s, circle 3, cross 2 3s. Circles come out, so 2 times 3 is 6. Nothing left over. So 216 was a perfect cube. And then we have the cube root of y on the top, and that is going to stay. Okay. All right, number 3 down here. Okay. So we have the cube. All righty. So we have 3, the cube root of 8x to the 4th over the cube root of 27y cubed. So I'm going to go ahead and check to make sure. I can't simplify these first, okay? Make smaller numbers for us. So let's do the numerator first. 8. 8 breaks down to 4 and 2, and 4 breaks down to 2 and 2. So we have the cube root of 2 times 2 times 2, x to the 4th, 1, 2, 3, and 4. Okay. So now look for our triples. We have a triple 2, and we have a triple x, and we have a lone x. Okay. So we're going to circle a 2, we're going to cross out 2, we're going to circle an x, we're going to cross out 2. Okay. So my circles come out, so I'm going to have 2x with the cube root of x on top. Okay. Now let's do the denominator. 27. 27 breaks down to 3 and 9. 9 breaks down to 3 and 3. So we have the cube root of 3 times 3 times 3, and then y. So do we have triples? Yes, we have a triple 3 and we have a triple y. Nothing left over, which is nice for the denominator. So we're going to circle a 3, cross 2, circle a y, cross 2. So then my denominator, the circles, come out, so 3y, and I have nothing left over. So right now, this would be my final answer. But then we always double check the outside numbers, 2 and 3. Can I simplify 2/3? No. So you are done. Okay, good job. And then number 6, we have 1 over the cube root of 9. So we're going to check 9 here in the denominator. Okay, so the cube root of 9 breaks down to 3 and 3. So we have 1 over the cube root of 3 times 3. So since this is the cube root, we need triples. Do we have a triple 3? No. So we need to rationalize this one. Okay. Now, to rationalize, we would multiply the top and the bottom by its radical. However, because it's a cube root, we need how many 3's? We need 3 of them. So right now we have 1, 2 3's, so we only have to multiply by 1 more 3. So we're going to multiply the top by the cube root of 3. The cube root of 3. Okay. So now 1 times the cube root of 3 is going to be the cube root of 3 over. Now the cube root of 3 times 3 times 3, we circle 1, we cross 2 out, and the 3 comes out. So that would be my final answer there. Okay. Now let's go ahead and add one more here that's a little more challenging. So let's look at 2 over the cube root of 3. Yeah, let's just do 3. Okay. Now, since this is the cube root, we need how many 3's? We need 3 of them. Right now, we only have 1. So we actually need to multiply the top and the bottom twice. So the cube root of 3 over the cube root of 3. Now we have 2 3's. We need one more, so now I have to multiply it again by the cube root of 3 over the cube root of 3. Okay. So now 2, the numerator, 2 times the cube root of 3 times the cube root of 3 would be 2, because that's on the outside. The cube root of 3 times 3 is 9. Over. Now my denominator, do I have my 3 3's now? Yes. So I can circle a 3, cross the other 2 out, and my 3 would come out. So now this one would be my final answer. Okay. Now if you have questions, please let me know.